Today, I'm lucky enough to have a few people with us, but we've had one, Mr. Jamie Stone, the Member of Parliament for Caithness, Sutherland and East at Ross, has had to pull out due to some parliamentary business. He's had to drop out. And Martin, who's with us, I'll give you a wave, has unfortunately lost his voice, so he can't speak, but he is still here and will be able to respond by text with that. So if there's any questions specifically you want to aim at Martin, you can let us know. But to introduce the rest of our panel for today, we have Harriet Brettle, who is the Head of Business Analysis at Astroscale, Anirudh Sharma from Digantara, India, Martin Platt, Director and Founder of Ambasat, and Ralph Dinsley, the Director of Northern Space and Security, NORS. So what I'll do, I'll hand over to Harriet quickly just to give a quick introduction to herself and then move on to the other gentlemen on the panel.
Fantastic, thank you very much. Hello everyone, my name is Harriet Brettle, as Derek kindly introduced me. So I work for a company called Astroscale. We are a startup that is looking at addressing the space debris problem in orbit, which I think we're going to go into a lot of discussion during this webinar today. Essentially, we're looking at addressing this problem from three key areas. So looking at ways that we can develop technology to do something about space debris in orbit and be able to remove failed satellites or rocket stages from space to reduce the amount of debris that we see in orbit. The second is working across the policy piece, so working internationally and with governments and agencies to incentivize more responsible and sustainable use of space in the future. And the third piece, which is kind of where I come in, is looking at how can we commercialize debris removal services and how can we really demonstrate the value that sustainability in the space environment brings to commercial satellite operators. So I'm very excited to be here today and thank you for having me.
Vince, do you want to go next?
Good afternoon, everybody. Thank you, Derek. Thank you very much, Sky Aurora, for inviting us along to participate in this webinar. I am Ralph Dinsley, known as Dins. I'm the founder and executive director of Northern Space and Security Limited, the only pure UK-based space situational awareness company, building on decades of experience amongst our team, predominantly supporting the military SSA mission, but also developing commercial and civil requirements as well. As a company, we picked up a lucrative contract with the UK Space Agency last November, where we actually provide orbital analysts to support the UK Space Agency Space Surveillance and Tracking program. And as a company, we're also developing our own space surveillance and tracking capabilities, because the key element here is getting the right data, having the data and being able to support it. Our mission is to support the success of space for society, and that means we need to ensure the sustainability of space. And therefore we want to democratize data of space alongside this revolution of data from space, so that governments can make more informed decisions to regulate and support space launch of the future.
Thank you for that. And Anirudh, do you want to go next?
Yep, sure. Hi, Derek. Thank you for inviting me for this webinar, and it's a pleasure me talking here. And then I'm Anirudh Sharma, founder and CEO of Digantara, India. So we are an Indian space surveillance company working in developing constellation of satellites for tracking and mapping these space debris that can be usually tracked by ground-based systems that is lesser than 10 centimeter in size is what we are targeting at. And our mission is to make space transparent and predictable. Yeah.
Thank you very much for that. And what I'll do, you just have to imagine Martin's voice is my own for this little bit. So a little bit about Ambasat and Martin. So Ambasat is based in the North Yorkshire in the UK and was founded in 2018 by Martin Platt and Marcel Hutvin, hopefully I get the name correct, who have almost 20 years of experience in the environmental and IT industries. Ambasat Limited design and manufacture low Earth orbit space satellite kits which contain all components needed to build a miniature space satellite. The goal at Ambasat is to deliver accessible space exploration by offering an affordable satellite development kit and rocket launch program. The AMBASAT-1 satellite product is designed to promote science, technology, engineering and mathematics and environmental studies among school pupils, university students, makers and inspiring scientists. So thank you very much for coming along today, Martin. So to start us off today, just to make everyone aware that we will be recording this and uploading parts onto our YouTube channel once it's complete, along with the rest of the webinar series. We'll do a highlight reel of such. So to start off today, the first question I've got here, I will pose across to Dins to start with. So for more than 15 years, environmentalists have been concerned about man-made threats posed to the outer space environment. To what degree do you believe that that threat to be real, and which are the most problematic branches of that problem?
That's a very good question, actually. An interesting point where you talk about man-made threats. What are man-made threats? And in my experience, a threat is something that has an intent, and therefore the threats to space are such things as the potential use of anti-satellite missions, or maybe the threat to space of not even understanding how we utilize it properly. Certainly there are a lot of hazards operating in space. I mean, the environment itself is hazardous to humankind, let alone to systems that operate within there. But also the fact right now is the potential risk of us over polluting it and actually causing problems in that area. But the biggest problem is we don't fully understand how much we are polluting it. And until we actually get a grip of our understanding of the problem, then I don't think we can actually do very much to address it. And we could actually make it worse by some of the means we're talking about addressing it. So potentially the biggest threat or hazard to space right now, I think, is the fact we don't fully understand what that threat is and what that hazard is.
Harriet, what about yourself?
Yeah, sure. So kind of building on what Dins has said already, you know, in terms of the space environment that we're operating in, I think one of the big challenges that we face is, as Dins highlighted, one, we don't have that much of an understanding of what the environment actually involves, right? So we have about 2,000 operational satellites in orbit around the Earth, which are providing a whole range of services that we rely on for everyday life. But going beyond that, there are the Space Surveillance Network in the US is tracking over 20,000 objects in orbit. And there's significantly more than that. The ESA estimates that there are over 100 million objects in orbit that are larger than 1 millimeter in size, and the vast majority of those pieces are non-maneuverable pieces of junk, right? So for every operational satellite that we have in space, there is a whole host of pieces of debris which are causing a direct threat to those satellites that we rely on for everyday life. So for large pieces of debris, you know, we can track where they are, and, you know, satellites can move out of the way. But as Din's highlighted, it's really the small pieces of space junk that we really have to worry about. Something the size of a 10p coin that we can't track from the ground can still cause catastrophic damage to an operational satellite. And so we need to have a better understanding of what the issue is. And we really need to start thinking proactively about how we address this problem, and then how we go about mitigating the amount of space debris in orbit and go about removing and reducing that space debris problem.
Anira, do you want to take up?
Yeah, sure. So like these guys told about the space debris problem, and then I just want to add on to what they said. So it's like space is very dynamic, and like they said, it's not the bigger pieces that is causing much problem, because that's being tracked every day by the United States Space Surveillance Network, but the smaller chunk, which we don't know where it is. And these are, not yet tracked by any of the systems. So we first have to understand what is happening in space, and then look at solving towards that problem. So the first step towards, the most problematic step right now is to understand what is happening in space. I think that is the most important thing that we have to do first.
I think one of the biggest problems that we face, building on both what Harriet and Anirudh said, is the fact that we don't understand the problem, but there is an agenda, and I'll use that phrase sparingly, on debris. Even the recent UK Space Agency Space Surveillance and Tracking grant funding call, everybody's talking about the UK tracking debris. But it's not about tracking debris. It's about tracking objects in space and understanding what's actually up there and happening. And the biggest concern is the fact that we've been doing this, and I'll say we as a collective military space community have been doing this since the first launch in 1957. Not many people realize actually the first object ever catalogued in space was space junk. It was the rocket body that launched Sputnik 1, not Sputnik 1, that's number 1 on the catalogue for space objects. So we actually started the catalogue on junk. But that information has been hidden behind the military firewall. A lot of that info has been behind that firewall for so long. The systems that are utilised aren't necessarily optimised for space surveillance and tracking. Therefore, we're not actually going into the root problem. And instead, a lot of people, and I've been in this business for over 20 years, but very concentrated since just after the Iridium Cosmos collision. But a lot of people have been walking around talking about the skies falling in. It's a space debris apocalypse that's going to happen. Nothing's happened, or very little has happened since 2009, and so therefore people think that we're all Chicken Little, and actually it's not a threat. So we really do need to have a concerted campaign to catalogue and understand what the debris problem is, and then actually to come up with some mitigating actions. And that will actually, unfortunately, cost money as well. And as we know at the moment, the public purses certainly aren't going to be as strong in the future as they have been in the past.
Excellent. Thank you for that. So moving on with that, so you've seen basically it is a big problem for that. I know a lot of the people who'll be watching with us are big space enthusiasts and will follow the subject quite closely, but there are some that are students that are just actually getting into it. But you've confirmed how much of a problem space debris is, but since Earth's orbit is becoming increasingly crowded and the number of launched objects is steadily growing, how real are the chances of a collision between spacecrafts and debris? Anirudh, do you want to start with that one?
Yeah, sure. So like I answered in the last question about space being very random, and then it's just random bullets flying up there in space, but we don't know what is happening, and the first step is to understand the problem. So when it comes to the probability of the collision or giving the statistical data about how much percent is prone to collision, so I would say that collision is more of a subjective thing. So to predict collision or what happens in space, we need to understand first where these objects are or what is happening with the environment there, and then look at providing a value for the collision. So I would say collision is more of a subjective thing right now. So even if we calculate certain number for a collision, I don't think that would make sense unless we understand what is happening.
Yeah, I just want to add to that, if I may. I think that's a really good point. There's only so much we can do to model the orbital environment if we don't have that information available. In terms of that collision probability and what the risk is, I think one of the challenge that we face is whilst the single probability of collision for each object may be small, these are also very large impact events, right? So you can see where one small, a collision between one small fragment of debris and an operational satellite can render that satellite completely useless, right? Completely destroy its capabilities. So you have a small probability, low risk, high impact events, which are very hard for us to really understand and risk mitigate. The other challenge that we've got is, thinking about the future direction of the space industry and where we're heading. As I mentioned, we've got about 2,000 operational satellites in orbit right now. In the last few weeks, we've seen filings in the US for tens of thousands of satellites over the next few years. And so the orbital environment is going to change dramatically. And so even if you have a very small probability of collision for one satellite, if you then have a constellation of 10,000, suddenly those small probabilities can really start adding up. And I think going back to thinking about space debris as an environmental problem, right? It's very similar to issues that we see on Earth, be it polluting our oceans or polluting our atmospheres. But it's sufficiently far removed that people don't necessarily think about it in that way. And I think we have an opportunity with the space industry to be proactive and take action now to understand and address the problem, rather than having to wait for that catastrophic event that really spurs us to make that change.
I think Harriet is absolutely right about the small probability, but big potential catastrophe. If something like this happens, she makes some very, very good points there. And it's very important that I think governments get the messaging correct for people to fully understand the significance of space and how important it is to society and what benefits we receive from it. And this recent pandemic, I think, has been a great example with all the tracking from space that they have been doing. And then, they need to then prove the point that we need to invest more into it. Historically, it's been a small number of operators, been predominantly government-based. Commercial space is now speeding up, and the technologies supporting understanding the orbital population, let alone projecting the risk, are very sparse. And like I say, they're hidden behind some of these firewalls we can't get access to. So it very much becomes, I suppose, a civil mission to actually understand more, do more, and help to do it. And the key piece, a lot of people talk about we need to change the laws or whatever, but that obviously will be even more glacial than some of the other systems that occur.
Well, I can see Martin's just came in with a question to myself to pose to yourself in regards to this. But what will be the future tracking capabilities from Earth in terms of size? What do you think, Dins?
So the future tracking capabilities?
Yes.
That's a very good question, actually. I mean, the technology exists to be able to track small objects, but it's not cheap. So the question is how much people want to spend. I would argue that right now we don't fully understand the orbital population above the size that we can track, because it's the priority is based on missile warning systems, so they're optimized for a completely different mission. And of course, even though it's a hazard to commercial space and to society in general, it's not the threat that these systems are looking for. The capabilities already exist to track smaller objects, but we need to have the political will and finance to be able to do it and go for it. Historically, space has been the worry of the individual operator, because it is a huge expanse, and therefore they only need to worry, and will quite rightly be worried about their own system. But the more we populate it, the more that it needs to be. I'm trying to stay away from a global commons phrase, not one of my favourite ones. But and I don't have anything other than coffee to drink if I should slip into that one. But yeah, it's something that every nation that's involved in space, and in fact any nation that isn't even a spacefaring nation now, should be concerned about the way forward, and there should be systems that should be, an infrastructure should be created to do more space surveillance and tracking to fully understand the problem.
Yeah, maybe just quickly to add to Dins's point, in terms of current capabilities, so right now we have a kind of ballpark capability to observe and track objects that are larger than 10 centimeters in size in LEO. The US has got a space fence initiative which is coming online, which will have the capability to track objects that are 2 centimeters and larger in size, so getting smaller. And again, there's exciting kind of commercial SSA players that are coming into the game, like North, and others like Leo Labs is a great example. So they're developing radar tracking facilities across the world, which will be able to bring down the size of objects that we're able to track, and again increase the awareness of the problem, because I think when we think about tracking objects in space, if we can see smaller things, there's a lot more, we're kind of opening our eyes up wider. The risk isn't getting bigger the more that we can track. We're just again getting a better understanding of the true risk that is currently out there, if that makes sense.
Yeah. So just to add on to what she said, so it's like people are having, companies are having capabilities to track debris that are up to 2 centimeters in size, just like Leo Labs and Space Fence by the United States. And means the problem, what it is now there is no global data source. There is no single data source for space debris. So each of these companies have their set of different databases. So what we are looking at is, so we should be looking at, merging all these databases and have a single source of data for what is happening in space. So that is something that I would like to mention here.
Excellent. Thank you all for your input with that. Just again, to everyone that is watching today, what I would ask, I can see a lot of questions coming in under just the regular chat. If you'd like to aim them at the Q&A section, after we've spoken to the panelists, we'll try and open the questions up for them as well as much as possible as time can. Okay, so continuing on there. Who is actually at risk then from a collision, and what are the implications if an incident actually occurs? Are there any sort of chain reactions, a possible outcome? I know recently there was news in the press where I believe it was one of the Starlink satellites and one of the ESA satellites had to move out of the way of each other. Who is actually at risk from this? Harriet, would you like to start?
Yeah, sure thing. So really, in terms of who's at risk, is anyone who is operating in space, right? So you alluded to an incident that happened, God, probably a few months ago now. Time in this era is kind of a very strange concept. But this was a case of a Starlink satellite which was coming in close proximity to an ESA Earth observation satellite and vice versa, right? And this issue really highlighted some of the key challenges we have around space traffic management, because there's no clear rules of what you should do if you come into close proximity to another satellite, other than just try and call each other up and resolve the issue, right? Which maybe isn't the most structured way of thinking about these problems. But I want to take it one step further than that, because I think that when we think about space debris and even just the space environment more generally, we think of it as something that is very abstract. But satellite services provide a huge range of benefits to life on Earth, right? The Aerospace Corporation published a paper very recently highlighting all the ways in which we rely on satellite technology, be it from enabling financial transactions, to checking your weather forecast, to understanding climate change, to monitoring disasters around the globe. And so when we think about who is at risk from this threat of space debris, first order, it's satellite operators, but secondary, it is anyone on Earth who is relying on that satellite technology in their day-to-day life.
And of course, we mustn't forget the good men and women that go and sit in the International Space Station every 6 months. I mean, that's been almost unmanned then. That's been crewed, I must get this right, now for 20 years. I've got a 15-year-old daughter and a 13-year-old son, and in their lifetime, we've always had bodies orbiting the Earth. So that's quite a phenomenal feat. And if the aspirations of companies go the way they should be going, we should be getting more and more people into space. And of course, therefore, it's beholden on us to make sure that space is as safe as possible. But we focus very closely on collisions, probably because the Iridium Cosmos was quite spectacular and it caused so many other pieces of debris. But actually, historically, in the 60 years of space exploration, there haven't been that many logged collisions. I mean, one of the earliest ones was 1996. I think it was Airbus satellite, French one, Charisse, was hit by a piece of debris. And then it's relatively quiet until 2009, of course, when the collision occurred with Iridium Cosmos. And there hasn't been that many since, or that many we can tag, because again, I'll go back as a broken record, I'll go back in state. We're not tracking it correctly, so we don't really have that information to support what we're doing. But we should be looking towards space exploration and to make sure that it's as safe as possible.
So on this aspect, so it's like, in the new space industry right now, there are a lot of new players coming in, new actors, and new space activities are going on. So there is an increase in amount of launches. So there is a paper which I was studying, and which says that even if we stop the launches that is happening right now, and with the current debris population that is there is a chain reaction that is constantly happening in space, which is increasing day by day just because of the smaller particles, which we don't know, we are not aware of. So I guess that this sustainability of space is really that is important right now, and we have to be thinking in terms of providing a timely and reliable solution for this SSA.
Excellent, thank you very much for those. So going forward with that, do you believe that we have the current technology available to resolve this issue in its entirety and clean up the orbit? or what are some of the most innovative projects out there at the moment that you've seen? Anirudh, would you like to start with this one?
Yeah, sure. So the current innovative projects that I have seen right now is that there are a few companies like, Astroscale's LSAT is one of an exciting mission which I have seen. And then there was another mission which was by Astroscale again called IdeaSG1. I mean, I don't know much information about it, but then IdeaSG1 was one of my interests. And then there was this, there is this university in United States called Texas A&M University, which is building a satellite which uses a kind of a sling technology to throw the object down towards the earth, using the atmospheric drag, and then that has to come down. So this was one of the innovative missions that I have seen. So apart from this, I guess there is a lot of things that is going on in the space industry in terms of providing solution for providing solution for mitigating and then tracking debris and increasing or enhancing the existing capability in for tracking and mapping space junk. But then I guess that one of the missions that we are doing is also interesting because we are going at a space-based solution where we want to track space junk from space so that we don't have any atmospheric distortion. So yeah.
Yeah, so I think this is a great question, and I think it's also useful to think about this from a positive sector, right? Because it's very easy to have a webinar talking about space junk and for it to be quite doom and gloom, right? But we've got to talk about what we can do proactively to address this problem. I think the first thing is really to understand the problem. We've talked about this a lot already, and I think Dins will no doubt be able to elaborate even more on that piece. I think the second point is how can we mitigate the growth of future space debris, and really that comes down to satellite operators thinking about sustainability and end of life throughout the whole satellite lifetime. So instead of just thinking about debris removal as an afterthought, or what do you do with your satellite once it's failed, we need to be thinking about how we can make sure that our satellites are designed in a responsible way, how we're operating them to make sure that we are being the most responsible. And then once they reach the end of their operations, either removing them from orbit safely themselves or using a third party like Astroscale that could come and do that debris removal. So maybe speaking a little bit to what Astroscale is doing specifically on the technology side. So as Anirudh mentioned, we've got the ELSA-D mission, which is launching later this year. It stands for End of Life Services by Astroscale Demonstration. This is going to be launching later this year, and the idea is that we'll be demonstrating a complete end-to-end technology capability that we need to be able to identify, rendezvous with, capture and remove safely a piece of space junk from orbit. So we're going to be doing that by launching 2 satellites together. One is our ELSA servicer spacecraft, and the other is a target kind of dummy failed satellite that's been built by SSTL in the UK. And that is going to be demonstrating that under increasingly challenging scenarios, we can catch that piece of debris and then bring it down ultimately to a sufficiently lower altitude where the atmosphere does the hard work for us and it burns up before re-entry. So that's a really, concrete technology that is in the works right now. ELSA-D is currently undergoing its final phases of testings before it's sent off to the launch site. We've also recently been awarded a contract by the Japanese Space Agency to go up and inspect a piece of Japanese space junk with future potential projects to ultimately go and remove that piece from orbit. So we're looking at ways that we can prevent the buildup of debris and also do something about the space junk that's already up there.
That's the beauty about all these missions. The man-made junk of space is inspiring more and more superb missions to actually go and clear up the mess we made in the first place, which is great to see. It's great the initiative of companies like Astroscale to do that. It's a shame we're already in that position. And I know organisations like the IADC, and the UN COPIUS have brought in debris mitigation ideas, I will say, because it all depends on countries to then bring them into their own laws, rather than there is no sort of international law on these sort of things. Unfortunately, the legal side is far more glacial. I mean, people talk about the 25-year rule. It's not really a rule. One could probably call it a code, but it's not really a code. It's a suggestion. And when the IADC first came up with this idea at the turn of the century, they were looking at an orbital problem, an orbital population problem that they predicted out to 2050. Can't remember the exact figure. I was trying to find that earlier today, but we actually surpassed that figure in 2015. So humankind is ahead of the drag curve when it comes to putting objects into space. Unfortunately, we're not ahead of that drag curve when it comes to removing those objects. But I shall go back to the point that, yes, these great inspirational projects are there and they will be suitable for taking 1 or 2 pieces of debris out of space, but they are still in the development phase. At the moment, if the right investment was there, we could fund more space surveillance and tracking and actually get a greater understanding of what the problem is. Last year, in my view, UK government wasted £92 million on a feasibility study for potential global surveillance, global system, GNSS, our own GPS. A tenth of that, and we could have invested in our own radar to do more space surveillance and tracking and understand what this problem is. So we really need to understand what our industry priorities are and how we can actually get the funding to support that. And of course, when people talk about debris, they also talk about paint flecks. I'm going to be the first one to bring up the paint fleck in space. And that story gets completely twisted out. I got into slightly bit of trouble at a conference a couple of years ago because an introduction of a debris removal mission, which wasn't an astroscale one, it was somebody else's, they used the context of paint flecks to support the requirement for their mission. But we're not planning to remove the paint flecks from space. We're planning to remove the objects. So my suggestion is let's get realistic and contextualize our discussions to make sure we focus on the right problems and then hopefully clear up the mess.
I just want to quickly touch on something Dins has said, because I think it's an important point to make is what I've talked about and what Dins has been talking about has been removing large pieces of debris. But at the beginning of this webinar, we were saying that the small pieces of debris are the problem, right? So how do you match up those two? Why aren't we going after the smaller pieces? Well, there's a number of reasons. The first is that the smaller pieces of debris, one, we can't track them. So how the hell are we going to find them and bring them down? The other is in terms of economic viability. You know, it is much easier to remove one large satellite from orbit that has the potential to become many small pieces of debris, rather than try and fish around for the little pieces, if that makes sense. So we're trying to go after the source of that future debris and mitigate the buildup, because it is, you know, I mean, bringing down the large pieces is difficult, but trying to go and remove even the smaller pieces of debris is significantly more challenging.